Now the definition is as follows. So HDFS is a key component of our Hadoop ecosystem. It is designed to store. Hello all and welcome back. So in this video, let us now continue our discussion and now let us try to understand about HDFS, which is a very important component of our Hadoop ecosystem. So HDFS, the full form we have already seen, it's Hadoop Distributed File System. From outside, it is just, and as the name suggests, it's just a file system. But understanding is very, very important for your big data concepts. Now the definition is as follows. So HDFS is a key component of our Hadoop ecosystem. It is designed to store and manage large-scale dataset across a distributed environment, making it highly scalable and fault tolerant. Unlike traditional file system, HDFS is optimized for big data where files are massive and need to be processed efficiently. And as we have already discussed, it is derived from GFS, that is your Cougar File Storage. I think it's Cougar File System. Now, one thing to note here, this definition surely is something which you will find at many places, but there are many things which you have to deep dive to understand and make sense of everything which this definition is saying. What exactly is fault tolerant? How the same is achieved? What are the traditional file system? Why do we need Hadoop? How is it highly scalable? Why is it just good for your massive and big data use case and not other use cases? So these are very important interview questions as well as in your data engineering journey. These are something which we should be aware about so that you can understand other file system and overall make the choice whenever you are trying to solve any engineering problem. So before I deep dive into these concepts, I would like to make sure that I'm able to clear out few things or few terms which I have seen are very helpful in overall understanding about HDFS. So the very first thing is file system. So these are just some terminologies which we are going to understand. So let me write down that as well. Terminologies. Great. So the very first thing is something known as file system. Now, file system as a whole, it is not a very alienated technology like anything. Like if let's say you are watching this on your laptop or let's say on your mobile, each and every of these devices have a file system. So a file system is a method and a data structure an operating system uses to manage files on your storage device. So just like we have a hard drive or let's say SSD on top of which our files are stored. So file system determines that how your data will be stored, retrieved, and organized. So in a very simple term, we can say that it's a layer between our operating system, that is your software. So software and hardware, right? So in hardware, we have the HDD, SSD, all these things. So any file which you're storing, that will depend, like it will depend that how they are stored on the basis of which file system your overall, let's say, machine is following. A few examples of this is Linux normally has a file system which is your ext, right? So Linux is having a ext file system. We don't need to understand all these things in a lot depth, right? So let me write it like this actually. Linux ext. Now, this is very efficient for servers and application requiring speed and security. So, of course, each and every file system, they will be having some properties which are associated with that. Linux has ext3 and 4, which is, of course, very helpful. So, if you have a Linux system, you can go to its properties and you will see that what exact file system it is having. Then, coming to Windows, we have something which is known as NTFS. Or your FAT32 at many older, basically, machines. Graphical user interface. Along with that, you will see that in Windows, you have all of these advanced features like permission and then encryption, all these things. Then if I talk about Apple or Mac, basically, right? Apple OS, or this should be Mac OS actually. It has a file system which is APFS. Okay. Then if we talk about Hadoop, it is having your file system which is HDFS, right, everyone? So you have to understand one thing, that all these are file systems, they're having some properties and everything with respect to that, right? But along with that, you have to see that in Hadoop, we have a special thing that it is distributed as well. It is distributed as well, whereas the other one, they are not distributed. And one very important thing to also understand is that your same machine, right? Let's say if you have a single machine, it can have different file systems and data can be exchanged between them. Just as an example, maybe in let's say your Linux laptop, so you have a laptop here which is say Linux, right? it is having by default an ext system. In this, we are using a pen drive. So let's say we are using a pen drive like this, which might be having a NTFS system, right, which you must have used from Windows. Now you can install, you can just plug it in your Linux system. It will be there, and you can exchange the data between that as well, right? So that is the major understanding, that a single machine can have different file systems. So just to make sure that you explain this, so OS and your hardware, and this is where your file system will come, right, everyone? So this exact is the place where IFS resides. So this is very important to understand, because moving forward, this is going to help you in understanding many things at all. And just remember one thing as well, everyone, that Linux machines, they're very good for your servers, right? They are having a very good speed and security, and that is the major reason when we talk about server. So in our big data, we will be of course using these machines and everything, right? So to form a cluster, there we will be in a way preferring the Linux systems, right? Now let's move on to the next one. Next thing is something which is known as block. Now again, block is the smallest unit of data storage in a file system. So smallest unit of data storage in a file system. Now, what happens behind the scene whenever, let's say, you are storing a file, it doesn't get stored as a single file altogether on your hard drive. It is actually divided into blocks. For example, in Windows, the block size is 4 KB. So let's say if you are storing a 10 KB file, right? So in NTFS, that is your Windows. If you are storing a 10 KB file, it is going to get stored in a 3 blocks, right? Because block size is your 4 KB. Now, this overall helps us in quick and efficient data storage and I would say retrieval. Okay, it makes it easy to distribute as well across, let's say, in your hard drive. Then again, it helps you use your storage space efficiently. So just as an example, and this now many things will make sense. So let's say if this is our hard drive only, right, everyone? So let's say that we stored some data here, which is of say 100 KB maybe. Then we stored some other data, which may be of say 200 KB, and then we store this data, which is let's say 300 KB. Now say that I am removing this data from my file system. Let's say I'm deleting this particular file. Okay. Let me just select the eraser. Let's say I'm deleting this particular image, particular file here. So this will get deleted like this here. And now I have to store 500 KB file, right? Now, if the file is not getting divided, then maybe I can store it like this. The 500 KB item can be stored, but this space is getting wasted, right? So I will just advise you to just read about it, the disk defragmentation, all these things. You can also think about this by a supermarket example, that how in that we try to make sure that we are able to fill each and every shelf, right? So dividing our overall file into this particular things, this is very much helpful. Now, the reason I'm telling you that is similar to your Windows, HDFS also stores your data in blocks, right? Here, the default size is 128 MB. The reason is same again, because we are using large blocks, because you will be dealing with large data, right? So that it improves your data efficiency. So again, all these things we are going to see as we move ahead. But the basic idea is that storing files in blocks helps you to store them in an efficient manner, and it also is very helpful in writing and retrieval of your files. Okay, so this is all about blocks, and every file system will have some overall, I would say, block size on which it will be dividing a file and then storing them. Okay, so now let's move on to the next one, everyone. The next one is your types of file system. In this, what happens is that there are two major types. The first one is your standalone, and the second is your distributed. So the idea is that, let's say if you have two, let me draw a cluster like this. So these are, let's say, 3 PCs which are connected to one another. And similarly, what I can do is I can create a copy of this particular cluster. Yeah. So what happens in a standalone architecture is, like, let's say if you have a file, right? So in terms of topology, right, they are not having any difference. Like you can see that we see just 3 machines which are connected to one another. Now in this standalone architecture, if let's say you are having a file, and let's say they are having some ext or NTFS format, or let's say NTFS format, and if we now ask to store a file here, this file will be stored in a single machine. So the basic idea is that files are stored and managed in a single machine. Whereas if I talk about distributed file system, and again HDFS is just one of the examples, we can have other distributed file system as well. Here files are stored across multiple machines in a cluster. So in this, if I'm asking my let's say one of the machines to store this file, since this is a distributed architecture, this is following a distributed file system architecture, these files, right, they can go into different machines by default, and HDFS can store like this, right? So this again is very important to understand, because this is exactly how your HDFS stores the file. Just to have an example, let's say if you have two mobile or PC connected running Windows or Linux, they surely will not be dividing the files. Let's say if you are copying a file onto your PC, that will just remain on your PC, even if the other one is connected, let's say via a wire, or let's say via some Wi-Fi or something. But if they are running HDFS or any other distributed file system, and if it is configured, then they are going to store your file in a distributed manner. Okay, a very good idea about this, a very good benefit of this, which you can think, is that it is very scalable, right? So I can tomorrow have hundreds of machines here, right? I can add hundreds of machines here, and I can increase my storage many folds. Whereas if you're trying to store this big file, and let's say the space is not free, you will not be able to use or store here, no matter how big you are making your cluster, because at a time a single machine is just getting used to store your file. So again, very important. These are the basics which I'm expecting that anyone who is starting their journey in data engineering, or who is a data engineer as well, they should have this thing clear, right? So the next terminology is your fourth one is your cluster and node. So this we have discussed many times. The idea is pretty clear. If we have a single machine, right, and when it is connected, when they are connected to one another, so let's say we have one machine here, then we can have 4 machine cluster, let's say. 1 minute. So let me just click, maybe let's say we can consider a 3 machine cluster. So in this 3 machine cluster, this is a cluster, right? And each and every single machine, it's a node. So I can say that this is node, let's say 3. This is node 1, and this is node 2. So here we are not having the terminology like client and server, big data majorly. We are having this cluster and node thing, right? So let's move forward even. Now the next terminology is something which is known as process. And daemon process. Now a process is something which is just a program in execution, right? So process, we can say that it's just your program in execution. Whereas your daemon process, right? It is a background process. It is a background process that runs without any user intervention.